Yes, for the record, that we actually held the office hours. Okay, I see Natalie and I see Gomembri. Okay, do you have any special questions you want to ask?
Well, I sent you my email. My name is, well, unfortunately, that's my login from work because I'm using my work computer.
Okay.
But my name is Mario Gomez, just so you know.
Okay.
And I sent you an email. I'm pretty much stuck on the first week.
Okay.
So I'm pretty much back there on the linear functions.
Okay. All right. Natalie has something to say?
No, I didn't even know that you did these type of meetings, so I thought I would pop in and just kind of get an idea, some help, maybe with the homework. I have just read through it. I didn't really
Good.
do
All right.
much on it. So,
Homework, is it homework number 3 or the homework number 1?
Yes, week 3.
Okay, so we're going to look at that too. The homework number 3 actually is a continuation of linear functions. Now, in homework number 1, we gave you the linear function. So there's a linear function, and this is how to interpret the linear function. And then essentially in homework number 2, we try to illustrate how the parts of the linear function are determined, in the sense that we ask you to actually how linear functions are interpreted and the different interpretations. And so we talked about rates of change. And so rates of change could be the rate of change of your bill. It could be the rate of growth. Essentially what we're dealing with is, I asked this question of the first student who came to the session. And I'm going to ask you the same question. Okay, I'm going to ask you. I'm going to ask you the same question. And I asked the question, and it's for the benefit of Mario and others who may have similar problems. I asked the question, say, I don't know how young you were, but we, who have been here for quite some time, there used to be a time when if you made a telephone call, if you had a telephone in the house, there was a fixed bill. And every long distance call you made, you were charged 10 cents per minute. And so I asked, okay, think about your electricity bill, okay? And the bill, or even if you rent a car. So have you ever rented a car? Say, yes, I've rented a car. Okay, and so if you rent a car, then the basic charge is $75, okay? And so for every mile that you run, you're charged an extra 50 cents, okay? And so I said, what if you rent a car for a day and you do 1 mile? How much would be your bill if the fixed charge is $75? So, oh, well, it's $75 plus the 50 cents. I said, good. So if you did 10 miles, what would it be? It would be 50 cents times 10 miles is $5. And so 75 plus 5 is 80. So very good. So what you have there is a linear function. Okay. So the bill, B, is the name. The amount of the bill depends. I see somebody else is trying to come in. Okay. So the amount of the bill is B depends on your mileage. And so we say that B is a dependent variable, which means the value of B depends on the independent variable, which is your mileage. Because you can put in 50 miles, you can put in 100 miles, you can put in 200 miles. So that's independent. And that's up to you. Put in how many miles, okay? It's up to you to make 1,000 minutes of phone call. But ultimately, B, which is the functional notation, and so I put up, let's see here. I put up a function to show how we interpret. Let's see. Let me take this out. Just give me a minute. I put up a function, and I can't seem to put up the function here. I don't know why. Okay. I cannot find your whiteboard. I'm trying to illustrate the a function here. It's not allowing me to do that. All right, let's see. So the function said we take B is equal to, which is what you see, is a function of miles. So this is a function. Okay, this is what a function is. And now, when we come to, like this is a generalization of what a function is. But now we can be specific. And here we're talking about your phone, your car bill. So B is equal to 75, which is the fixed amount, plus 2M. We are saying here that, and here I'm trying to exaggerate it. So your fixed bill is 75 plus $2 per mileage, okay, per mile. Now, B is equal to F of M is a generalization, okay? It can, M can be put in any form, we can say, for example, M to the power 2. We can say M to the power 3. We can say 0.5 M or 0.25 M or 2.5 M, whatever it is, okay? So B is a dependent variable, and M is the independent variable. And it can be that there is no fixed charge. Your bill is 2 times your mileage, okay? For example, we can rewrite the bill and to say that B is equal to 2M. So every mile, you pay $2. That's no fixed charge, okay? We can say that, and that becomes your function. So function can be anyway. So now what we did in homework number 1, which I'm going to pull up, was actually just get you to interpret a graph and interpret a function, okay? And the same thing we did for homework number 2. So I'm going to pull up homework number 2, and I'm going to erase this. I'm going to pull up homework number 2. Let's see how we look at homework number 2. All right. This is homework number 2. You see my screen? Hello?
Yes, Professor, yeah.
Okay.
Yep.
All right. Okay.
Yes.
All right. So we are looking at homework number 2. And the simple interpretation is, now, again, you have a linear function, okay? So C of n, and C is the dependent variable, and n is the number of minutes, okay? And so what is the fixed charge? The fixed charge is 21, okay? And the rate of change of your bill is 8.08, which is 8 cents per minute. And n represents the number of minutes. We could have put m, okay? But we used n because we said number of minutes. So we put n. We could have put m, so, and say m is minutes. So the fixed charge there is $21. And the rate of change is 8 cents, okay? Now, in the second problem, or actually in the third problem, problem number 3, now we try to get you to calculate the rate of change, okay? And the rate of change there is simply the change in the F, the difference in F from one point to the next, say from -4 to 16, divided by the change in X, which is from 2 to 4. So let us try to illustrate that. Okay, let us try to illustrate that.
I have a quick question, Professor.
Okay.
So number 3 is in conjunction with C with number 1, right? We're still always looking at number 1?
No, what we are trying to do now is to give you an idea how that 0.08 can come about if you are just giving raw numbers. You
Right,
see
because this is where I get lost. Because C in the first question, I'm sorry to throw everybody back.
Yeah.
But C equals 21 in the first question, right? So C
No,
is
no.
21. No,
C is 21 plus
plus the
0.08 times n. So let us say that n is 200. So C will be 21 plus 0.08 times 100. Okay, let me make this one very, very clear. 100.
But where did the 100 come from? Is my question.
Very good. Very good. Now, remember we said where did the 100 come from? Let's see. So where did the 100 come from? $100 comes from you. Do you get that? Hello?
Sorry, I have it on mute so you don't hear in my house. I
Well,
understand that it comes from me, but I don't see it written anywhere in the questions. So this is where I get confused.
no. Well, are you saying you don't see it anywhere in the homework assignment or you don't see it in the formula?
I don't see it in the questions that are asking.
No, okay. In the question, we asked for 300. We
Okay.
said, suppose you talk for 300 minutes. You get it?
Yes, I see that.
Okay. So suppose you talk for 300 minutes. Suppose somebody else talk for 400 minutes. So you're going to replace N with 400. If somebody talked for 500 minutes, then you replace N with 500.
Okay, understood.
You get the point now?
Yes.
Okay. So this is the whole idea of a function. You write a function in a general way. And then you make it possible for anybody to put up an arbitrary number for the independent variable. So if the function, as in this case, the function is 21 plus 0.08 n. So we make it such that somebody can change n to anything. You get it? And
Yep.
so in the case where we said, suppose you talk for 100 minutes. So our own n is 100. And so 0.08 times 100 is 8. So 8 plus 21 then gives you 29. You get the point now.
Right. You're saying if it was 100, 0.08 plus 100
No, 0.08 times 100.
times, okay, 0.08 times 100
Yes.
plus 21
Plus
equals
21 equals
equals C.
29. Yes,
Okay.
equals C. Okay. So what we're doing now in homework number 3 is, in problem number 3 of the homework number 2, is to now illustrate or let me say illustrate how that 0.08 will come, that rate of change. Okay. So in this case, what we're doing is the rate of change, which is that 0.08, how does it come about? Okay, how it comes about is to take the difference between the values of the dependent variable. Here we go from -4 to 16 and divide that by the change in the independent variable, which is going from 2 to 4. Now think about again your bill. Okay, think about your bill. Now, you do 100 miles and somebody does 400 miles. Okay? Their bill is going to be bigger than yours. Okay? So you do 100 miles and your bill is 29. Somebody does 400 miles, their bill is 32 plus 21, which is for the 53. So the dependent variable there, the bill, goes from 29 to 53. So we take 53 minus 29 and divide it by 400 minus 100. So that tells us.
Sorry, I'm lost right there. So
Okay.
what we hear, where I get lost is from CN, and that equals 21.08 n. I
Yes.
understand that. Now where does X and FX come from?
Okay, I will explain that to you easy.
Okay.
Just give me 1 minute.
And I wanted to apologize to the class if I'm asking so many questions because I'm completely lost. I was out of school for 30 years, so I'm a little
Okay, very
trying to
easy.
understand.
Very,
Totally understand you.
Question.
Don't feel bad.
Don't feel bad at
No,
all.
I think we're all
okay,
here. 'cause
We're
we
all kind of in
need
the
help.
same boat.
okay,
No, and
so
I'm realizing I did this one wrong and I already handed it in, so
okay, I will open it back for you and you can redo it. Okay.
thank you.
So now you're saying, where does the F come? Where does the G come? Where does the W come? Okay. Now the C is like the way we are representing the company's charges. So C is charges, right?
Right.
Okay.
Yes.
Now G could be the number of G's. Okay. In a flock. All right. It could be anything. Okay. So we can use G to represent something like C. But here is charges. C means charges. G could mean anything that you are talking about. W could mean anything you are talking about. F could mean anything we are talking about. All
So
right?
that letter, that's the letter that represents the function, the first letter.
Yes.
Okay.
That
Whether
is
it's a cost, whether it's the minutes, the cost, the gas, the mileage. All right, I understand.
you get the idea now. Okay. So
For that, yeah.
okay. So now we are trying to say, okay, what is the rate of change of F? Like, what is the rate of change of your bill? What is the rate of change of your mileage? Okay. And so we say, okay, we say that F here, for example, changes from 16. So that is the, okay. F changes from 16, mean from minus 4, minus 4. Okay. So divided by
4.
4 minus 2. You get it?
I don't see where the -2 comes in.
Okay. So now we're going to go through it again. Where does it -2 come in? Right. Let's say where the -2 comes in. Remember we talked about your bill.
Mm-hmm.
You did 100 miles, the other person did 400 miles. That's the function, right? So we're trying to find the rate of change. Why is it that you have 400 miles and the other person, you have this bill and the other person has that bill? What is the rate of change? What if somebody did not write a function for us? We can create that function ourselves. Okay, so we're asking, what is the rate of the change? So now we take the bill, right? 53 minus 32, that is how much the bill changed, right? Okay, and then we say, okay, the mileage changed from 200 miles to 400 miles. So we take 400 minus 100. All right. So in that case, X changed from 2 to 4, and F changed from -4 to 16. So if we take 16 minus -4, which is the change, the amount of change, and X changed from 2 to 4, so we take 4 minus 2, which is the amount of change.
Okay.
So the amount of change in X is 2, but the amount of change in F is 20, because it went from -4 to 16. So you take the first 4, then add the 16, so actually changed by 20. So you divide it 2. So you divide, then this will be equal to 20 divided by 2. And what is 20 divided by 2?
10.
10. So the rate of change is 10.
So, okay. Starting to make a little sense.
Okay.
You're trying to compare the change from the -4 to 16. You started at 20. Obviously, 20 with plus -4 is 16. And you do the same function up top for the x.
Yes.
Because you, okay.
So we're saying that f changed by 20 when x changed by 2.
Okay.
And if x changed by 20 because x changed by 2, then what is the rate of change? The rate of change is 20 over 2.
The rate of change here is 20 over 2.
Yes. So, and you do that for all the adjacent numbers. So if you find out that when you go from 16 to 20 to 36, the change of f is 20. When you go from 36 to 56, the change of f is also another 20. And so every adjacent subtraction is the same thing. Now, this is for a linear function. Doesn't apply to nonlinear functions, okay? And we're going to get to nonlinear functions along the way, okay? But for a linear function, that's like for a straight line function. That's what we call a linear function. That means the function, the line that describes this particular situation is a straight line. If it's not a straight line, the formula is slightly different. Is the point clear now? Hello?
Yes, I'm here.
Okay.
I'm listening.
Okay. So here we are still talking about a linear function, which is a function that is represented by a straight line.
I have a question.
Yes.
So I see, so you're taking, right now, you're taking, the first 2 rows to find the rate of change. For this question, I guess my question is, I was thinking that we would take the last row and the first row to get the average rate of change.
No. The rate of change is the same from point to point. And so you take all the adjacent rows. Okay, like I said, you begin from 4, 16 minus 4. Then you will do 36 minus 16. Then you will do 56 minus 36. And you will find out, you will see here, if you look at it casually, you will see that the rate of change from 16 to 36 is the same thing. It's 20, the difference.
Okay.
What is the difference between 36 and 16?
What was that?
If you subtract, take 36 minus 16, what do you get?
Oh, I don't know.
Oh, write it down.
20. Yes, 20.
Okay. 56 minus 36 is what?
Okay. Yeah, see, I'm not great at seeing those patterns just casually like that.
I understand that. This
I'm
is
not
why
great at fast
this is why you do it manually. This is why you do it on Excel. Thank
Okay.
God for technology.
Yeah.
In my days, we did it by hand.
So, Professor, excuse my ignorance here, but question number 3 is completely unattached from question number 1. Then this is a completely different. I thought that everything kind of coincided, so this is where I'm a little lost. So, question number 3 is a completely separate question from number 1.
It's a completely separate question from number 1, and the whole idea is to explain to you how the 0.08 in number 1 is derived from raw data.
Mm-hmm.
If somebody did not write that equation for you, could you write it for yourself? The answer is yes. Here you find the rate of change. That 0.08, you find it by yourself.
I have a question. The
Sure.
way after grading question number 3, what is the rate of change for each table below?
Yes.
I got the question correct, but I didn't set it up the way you did.
How did you do it?
So I did
I
m
saw
equals
it, and it
56
was,
minus 30.
I saw it, and it was done
So
correctly.
am I supposed to set it up like each row individually or all together was fine?
Let
Okay.
me erase this. Okay. And what I'm going to try to do, I see, different students did it differently. Some students use Excel. Okay. So I'm going to end this, and I'm going to put this on Excel. And I'm going to stop this share for a minute. Bring it up again when we need it. All right, you see my Excel?
Yes, sir.
Okay.
Yes.
I'm gonna make it big. Okay. Is it big enough?
Yes, for me it is.
All right. So now what we're gonna do is we're going to do it essentially the way a lot of students did it, except they did not do it on Excel. Some students did Excel, some students just did it, one by one, okay, on separate lines. So we're going to do what we call df, okay, or change in f, okay, and say equals G5 minus F5. Okay, let's see. I mean, 16 minus 4 is 20. Okay. Just a minute. This is like trying to give me a hard time. This is 20. Okay. And this is another 20. And this is another 20. Okay. But you can write in the formulas. Okay. And the change in x, I'm going to put dx. Okay. The change in x, 4 minus 2 is 2. 6 minus 4 is 2. And 8 minus 6 is another 2. So here, the rate, which is df over dx, because you're looking at the change in the dependent variable divided by the change in the independent variable. So the change in f divided by the change in x, okay? And so we have equals G6 over G7. What do you have? What you have is 10, okay? So the change is constant, 10. And so your answer is that the rate of change is 10. Did that come across?
Yes.
Okay. Okay. So, and that is the way you answer the other questions. I think copying this thing from Blackboard kind of distorted G, right? Minus F. Okay, it's not working out because I copied it from the wrong place. Okay. Then I could just take 2, 4, 6, 8. Okay. Minus 4, 6, 56. Okay. And so we can say equals G5 minus F5. All right, so we have the 20, that digit formula, and you can drag it down, make it easy for you. The same thing here, equals G4 minus F4, and you can drag it down. So it gives you 2. And so you get the change in F divided by the change in X, and you get 10. So that means the change is constant, okay? Now, the change is not always constant. It's not, that is, the rate of change is not always a constant value. If you're dealing with a function that is not a straight line, then the change is not going to be a constant value. The change could actually be a formula. In any event, we didn't get there yet. We're going to get there in about week 6 when we're dealing with quadratic functions, okay? So,
But
we're going in stages.
I have another question.
Yes.
Sorry, Professor. I don't
Go ahead.
Okay, F divided by X. I understand that. But when you put X
No,
in parentheses next to the F,
excuse me, the change in F divided by the change in X, not F divided by X. You can see F divided by X, like here is minus 2, here it's 4, here it's 6, here it's 7. No, that's not it. It is the change in F divided by the change in X.
So why is it in parentheses next to the F? Isn't that multiplication? So I'm sorry.
Okay, I get where you're going with it. No, that is the way we do annotation in mathematics. F of X simply means that the value of F depends on the value of X. Okay, for example, we could just make this plain F. We could just make that
the same question.
The same thing.
Okay.
We are simply saying that F is changing. Okay, and F of X will simply mean whatever value is there that depends on X. That is just technical mathematical notation, but you're not alone. Okay, it took a lot of us a while. I'll give you an example. When I was doing geometry in high school, the teacher always illustrated with a triangle ABC. And when I see a homework problem, it says triangle GEF. I got totally lost. Wait a minute. The teacher was talking about triangle ABC. Why not triangle DEF? What's the difference? Okay. You just find out that it's just a name. Okay, so F is just F of X is a name. You can just put F. You get it?
Okay.
Okay. So having gone through that, I'm going to stop this here. Okay. So you want to go back to somebody said they were having problem with what? Week 3 assignments?
Well, I'm sorry, but yeah, I had a problem with the entire class so far. So I'm starting to understand these a little bit better today. So thank you for that.
All right. So any other questions then? Okay, let me see if I can go to week 3. If you don't have any more questions, this is your week 2 assignment, and see if I can provide some insights into it. Okay. Okay. Now, week 3 talks about graphs of linear functions. Okay. Graphs of linear functions. So here, we now go back to when we calculate those rates that we're talking about. When we calculate those rates, the question then becomes, how do we use that rate that we calculated to create a linear function of the kind that we have in C is equal to 21 plus, some rate of change times n. How do we do that? Okay. So here is this question here. It says that the clothing business finds there's a linear relationship between the number of hats it can sell and the price P it can charge. Okay. Now, so the number of hats X that it can sell and P that it charges per hat. So what is depending on what? The number of hats that you sell depends on the price that you charge. Am I correct?
Yeah.
Yeah. So the number of hats you can sell, X, depends on the number of, the price that you can charge, which is P. So we can actually look at X is, what do you call it? X depends on P. So now, this is where we're trying to illustrate how to create your own function. Remember, in the first, in week 2, we talked about how to find out the rate of change. Here, we're trying to find out how to create a function. So first of all, we find out the rate, and then we use the information on the rate to create a function. All right? So let us see if we can illustrate that. Okay, let's see.
Dr. Egby,
Yes.
thank you. I just wanted to say that I have to jump, but I think you've addressed all of my questions, and just thank you very much.
Okay, absolutely. Feel free to drop in and drop out anytime.
Thank you so much.
Okay. All right. So here we have the question that enables you to find out your own function, to create your own function. Okay. So first of all, step 1 is find out the rate. Okay. So step 1 is find out the rate. This is very clumsy, but you find out the rate. Okay. And then step 2 is, so now you create the function. Okay. You create the function. Okay. We're going to call it func. Okay. Then you create a function. Okay. So here, what is the rate? Okay. And so the dependent variable is X. And so you take X2. Remember, the last time we took 16 minus 4. So we take the later value minus the previous value. So we take X2 minus x1, and we divide it by P2 minus P1. So that gives us the rate of change. Okay, that is to say, if you increase your price from P1 to P2, how much would it affect the amount of hats that you sell from X1 to X2? You sold so many hats previously at a certain price, and then you change your price to a different price. How would it affect the number of hats that you sell? That's what we are going to look for. And so here, that 1,500 hats can be sold at a price of 40, while 2,000 hats can be sold at a price of 30. You get the point? Okay. So
then you would set it up as 2,000 minus 1,500
that's right.
divided by 40 minus 30.
That's correct. 2,000 minus 1,500. Let me.
And then that would equal 500 over 10.
Yes. So 2,000 minus 1, 500 divided by how many hats?
10.
40. Yes, 40.
40
Actually,
minus 30.
30 minus 40, because 30 is the second value and 40 is the first value.
So it would be flipped. So 30 minus 40.
Yes. You take the second value minus the first value. And so what we have there is
negative 10.
Yes, 500
divided by negative
10 over minus 10. So the answer would be minus 50. Is that correct?
Yes. That would equal the rate of change.
That will be equal to the rate of change. Okay. So we write down minus 50 as the rate of change. Write it down on a piece of paper. Now remember that you use this formula x1, x2 minus x1 over p2 minus p1 to get your minus 50. Is that clear? All right. Can I go on?
Yes.
Okay. All right. So let's write that down. So now we create the function. We create the function since we use the formula x2, okay, minus 1,500. So now we'll put some actual value, but we don't know what the other value is going to be. So we'll call it x2, which is the second value, minus 1,500, divided by the second value here, which is 2,000. Minus x1. Actually, it should just be minus x. Okay. This should be, no, this is minus p. will be the second prize was 30. So 30 minus P is equal to minus 50. And so all right. So now what you do is you solve this equation. You solve this equation for X and P. Okay. What you're going to find out is that you will have X minus 1, 500 is equal to minus 50 times 30 minus P. All right. So now this is the equation you're going to solve. Okay. This equation you're going to solve. And so you're going to have X minus 1500 equals minus 50 times 30 minus P. So what are you going to have there? What you're going to have there is X minus 1,500 is equal to minus 50 times 30, which is minus 1,500, plus 50 P. Okay, so now if you bring if you take this 1,500 on this side, you're gonna have 3,000. And so X will be, and then if you take you have 3,000, so the equation then will be X is equal to 3,000 plus 50P. So you see X as a function of P. You get it?
Nope,
No,
not gonna
I
lie,
got-
Professor. You
I
lost
got
me there.
lost I got lost at where you got the 50p.
Where, yeah, like what? So
Minus,
I
minus,
see that
okay. Minus 50 times P is what?
50,
Minus 50 times minus P is what? Okay, what is 10 times X?
X being 1,500.
No, no, no. Okay, 50 times 30 is what?
1,500.
1,500. Good. 50 times P is what?
I guess 1,500.
No, no, no. 50 times P is 50P. It's like, let us say that C represents chicken. Let us say C represents chicken. So if you say 50C, what do you mean? You mean 50 chicken.
Okay,
You get it?
right.
If you say 70C, you mean 70 chicken. So P represents price.
Okay.
You
So-
get the idea?
So the negative, okay, the P is now being substituted for the rate of change.
So the 50 is now, remember we saw 50 as
Honestly,
the
I
rate
don't
of
even know.
change.
I don't even know. Professor, I don't even know what we're looking to answer here. What question are we answering? Because I keep seeing you keep changing.
We are trying to create an equation for X, okay, as a function of P.
For the price of the hats.
Yes, that's what we are trying to. Either we create a function, the quantity of hats, as a function of the price, or the price as a quantity as a function of the number of hats. So okay, let's erase it and start all over. I'm going to use smaller scripts and so that everything can fit on the screen. Okay, let's start it all over. Okay. Okay, so the second value here is 1,500 hats can be sold at 40, and 2,000 hats can be sold at 30. Okay, so first hats is 15, second hats is 2,000. So we find the rate of change first. So we say 2,000. Let's all be patient. Minus 1,500. And we divide that by the second.
30.
Right?
30 minus 40.
30 minus
40.
40.
And this is the rate of change.
This is the rate of change.
Of P.
This is the rate of change of the function of H, hats, because you're selling hats, right? So the number of hats you sold at 40 was 2,000, right?
Mm-hmm.
The number of hats you sold at 40, sorry, the number of hats you sold at 30 was 2,000. Is that correct?
Yes.
Okay. And the number of hats you sold at 40 was 1,500. So the
Correct.
second value of hats is 2,000. The first value of hats is 1,500. You started from 1,500 and you went to 2,000.
It's 500.
You had 1,500
So
here.
shouldn't it be 1,500 minus 2,000? No, I'm confused there. Shouldn't it be 1,500 minus 2,000 if 1,500 is the first?
We said we sold.
Historical data says.
Okay. 1,500 can be sold. Okay.
1,500.
1,500 can be sold at 40. 2,000 can be sold at 30. Is that
Right.
correct? Good.
Right.
And so the
Yes.
second value is 2,000. Its first value is 1,500.
Right.
Okay.
So we're subtracting the second value from
the first value.
The first value.
Yes.
Okay.
And the second value of price was 30, and the first value of price was 40.
Right.
So the answer becomes what do you call it? 500
over
minus,
negative 10.
Yes. Okay. 500 over 10, which is minus 50, right?
Mm-hmm.
Okay. So now we now take X minus 1,500 divided by P minus 40 So essentially we're saying that X minus 1500 over P minus 40 give us minus 50. That's what we're saying. But
So it's the same.
Anytime we do X minus 1500 over P minus 40, whatever P is, whatever X is, we're going to get minus 50. And so what is the implication of that for X as a function? You get the point?
So X could be any number.
Could be any number,
Minus,
P could be any number.
And P could be any number.
Okay.
And it'll always be negative 50.
Yes. And so we're saying, what does that tell us about X? So now we then take X minus 1500 equals 50 minus 50 times P minus 40. Okay. So I'm going to take that out since I'll set it up there. Okay, so now we solve this equation as X minus 1500 equals minus 50 times P is minus 50P, right? So minus 50P plus minus 50 times minus 40 is 2000. We did it wrong the first time by using 30 there because we're looking at the second value. Okay. All right. So now you can break this down. Okay. You can take minus 1500. If you take it to the other side of the equation in algebra, it becomes a plus. So you have then that X now is equal to 3,500. Since we're moving the number 1500 to the other side of the equation, so it becomes a plus minus 50P. So now X as a function of P, this is now the equation that represents X as a function of P. So that original function that you were given, this is how it is derived. So we are moving from, first of all, giving you a function. So this is what a function looks like. The question is, how do you derive a function? And here we're saying, how do you derive a linear function? So we just derived this function. So if you were to write the equation of hats sold as a function of P, that means you're going to write it as X is equal to 3,500 minus 50P. I mean, it's something that you can comprehend. I believe me, you can comprehend it. But we just went in stages. We first of all find the rate, and then we use the same formula that we used for finding the rate, and then we simply put in regular values without 2 and 1. So we said x minus 1500, which is the first the second function, which is x. So we don't know what it's going to be. We just want to generalize minus 1500, which is the first one, 1500 here. And then we substituted p minus 40, which is whatever p is going to be minus the first value of p, which was 40. And then we solve the equation. And so once you solve the equation, it tells you that x, the value of x, the number of hats you're going to sell, depends on p. And it makes a lot of sense here, because essentially what it is telling you is that if, for example, you put the p at 10, you're going to sell more hats, because it's 3,500 minus 50 times p. But if you put the p at 20, you're going to sell fewer hats, because it becomes 3,500 minus 1,000.
Okay.
All right.
Can we maybe answer the questions to see if maybe that clicks a little bit for me? Because
okay, answer what
honestly,
question?
I don't want to take everybody's time, but I'm not
Okay.
grasping this.
What question you want to ask? Go ahead.
Well, the questions for the homework. So for example, if they give away the hats for free, how many hats will people take away?
All right. So what if p is 0? 50 times 0 is what?
0.
Good. If they give away the hats for free, what does that mean for the price of hats? What is the price of a hat if it's given away for free?
I guess
Are we
if the
guessing that?
hats, wait, if they give away the,
Yeah, if
how
they
many
give
hats
away,
will people take away?
if they
That
give
doesn't make sense though, because if
excuse me. If they give away the hats,
ahead.
what is the price of the hat?
saying free.
Free. I mean, it's free, but what is free? If you go to the place where they're selling hats and they say they're giving the hats away for free, how much money will you give for each hat?
Well, 0, because it's free.
0. So if p is 0, 50 times p is what?
0.
Good. So the number of hats they will sell is, they give away is 3,500. What does it tell you?
What? Wait. Whoa. Okay. So they will give away 3,500 hats for free?
Yes. Excuse me. But the point of the matter is that this is a practical situation. Yes. You're not talking about, you're not talking about, whether they will make money, whether human beings behave like that. What I just said, if the hats are given away for free where p is 0, how many hats would they give away? 3,500 hats. That's what it is. Okay? Because you are answering here a philosophical question. You're not answering a normative question. The normative question is, who will ever give away their hats? Haven't you ever seen where they're giving things away?
Yeah.
Very good. So the point of the matter is this. Not everybody wants a hat. Right? Now you get a hat, the things you will enjoy wearing the hat. This is number one. When you take the hat home, the hat is going to occupy some space in your house. Am I correct?
Yes.
And somebody could say, I don't want any more hats. I already have enough. Or I don't wear hats. So what this is saying, that in a practical situation, what happens in this particular market is that only about 3,500 hats will be given away, because they are using this number. They say, if I sell the hats for $40, I'll sell 1,500. If I sell it for $30, which is a reduced price, but I'll sell more hats. That is natural, isn't it? When hats are selling for a penny, people will buy more of it. Those who want hats. Is that correct? So this makes a lot of sense. Okay. Now think about food in a restaurant. Okay, what if they're giving away free food? Will people eat all the food in the restaurant until their stomach bursts? The answer is no. There's just so much that people are still gonna eat. Doesn't matter whether they're giving the food for free. You get it? So this
Okay.
is a practical illustration of what happens in the marketplace.
Okay.
All right. If they sell the house for $10, then it will be 3,500 minus 500. So they will sell 3,000 houses. If they sell the house for $20, the 3,500 minus 1,000, which will mean that they will sell 2,500 hats. Any other question? Okay, all right. Thank you so much for your time. I hope you're able to solve the problems. If you can't, you can always give me a call.
Okay, yeah, I don't want to take up everybody's time, but I am definitely struggling with this. I'm gonna try to keep studying and see if
Keep
I can
working
grasp.
on it. If you have issues, give me a call. I can set up a session just for you and me.
I do have one question.
Sure.
So, for the midterm, I know it's some time away, but
Yeah.
approximately how much time would we get, and how many questions would it be?
You have approximately 2 hours
2
time.
hours,
Yes. There might be about 4 or 5 questions.
4 or 5 questions. Okay.
Yes. I mean, don't hold me to that. Okay.
No, but just to have an idea of what to
And when I
expect.
say
'Cause
4 or
I-
5 questions,
'cause-
let's say that there are about 4 or 5 numbers, but say number 1 could be number 1 A, B, C.
yeah, no, I assume
Okay.
so. Like it would be similar to what our homework has been so far.
Yes.
Where like each question may have multiple
Parts.
parts to it.
Mhm.
You know, just thinking ahead because I take a lot of time just to do the homework assignment.
Okay. All right.
Okay. Thank you so
Okay.
much for your time. I really appreciate you going over these problems. It really does help.
Okay. All right. I'm very glad that you came.
Thank
All
you,
right. Have a good
Professor.
night.
All
Thank
right.
you,
so much.
guys.
Good
Okay.
night.
Everybody have a good night.
All right
Okay,
then.
good night.
Good
Bye.
night.